Hi, this is Prof. Redder again. This time we're going to talk a little bit more about classes and objects, but we're going to try to motivate the need for them or the purpose of them. And I'm going to do it through an application that I've already written and that I will then, as we move along, modify to use an object-oriented approach as opposed to just a procedural kind of an approach that we've done in the past, or some people call it perhaps an algorithmic approach. So what I've got here is an app that's just very much like the one that you've already created when you did the adding an app to the main menu kind of a project, and also actually the one that you created to as you followed the instructions on assignment 2, I think it was. So in this case, what I've done is already created an app, and I've got it ready to run, and we're going to go look through what this app does. And I'm going to complain about it a little bit because it doesn't really meet current standards on how applications ought to work, or how they ought to be architected, I guess is a better way to say it. So if you look at this is what I get by just simply create a new project like you did before, a Java application project. And with this one, I'm going to say I'm going to create a checkbook, a really simple checkbook. And the only things you can do with this checkbook are withdraw money and deposit money. And you can't even keep a balance between applications. But I don't care about that. This is showing you something to do with how an app that you might run or execute with your current training to a more current way of doing it, in particular with objects. Okay, so this is a simple app. I'm going to come over here. I also created on this app by doing this kind of thing, new, other, checkbook, swing G GUI forms, JFrame form, okay, as we did before, and click on next and so forth. But you know how to do that from previous videos and previous work that you've done. So there's not much going on here, except that it is in this call to this method run, it is causing this form to be created and the set visible method to be called on it, which is what allows us to see this form. So what I've got here, let me just click through some of these controls that you see on this box. I've got 3 labels. One says this, one says balance, one says transaction amount, and you can see those values down right here. Really not very interesting. This actually is also a label, but if you wanted to identify the thing, you would probably make this the same kind of thing as we're going to talk about with balance and transaction amount. But for now, I've just got it there just to indicate that we could, in fact, make additional things available. But if I look right here, this thing is something that has a text value of 0, and that's because I'm always going to start the balance at 0. And we could fix that on a more fancy application, but I don't care again about that. I care only about showing you about the object stuff. In addition, under code, I've changed the name of that text field to m_tf balance, as I described before. I've done the same thing with this one. This one's called m_tf transaction amount. And those are both there just for the purpose of, those names are used just for the purpose of being able to refer to these so that I can change the values in them. All right. In addition, I've got these 2 buttons, a withdraw button and a deposit button. And all I want for them, I mean, I've got a text down here for them, and I've got code here that gives them a name, m_button deposit or m_button withdraw. But I also need to handle the click event on each of those buttons. And so in Java here, this is the way we're going to do that. We have an event that we created here, and the way I actually created it was by coming over to this button and double clicking on it. And it gave me this method, but it wasn't populated with executable code. And I did the same thing for the deposit and got this method. So if you look at this and you think about it, this kind of makes some sense about how you go about doing a deposit, let's say, the one that's highlighted in blue. You get the balance, you get the transaction amount for the deposit, and then you add the transaction amount to the balance and set that as the new balance. So I had $100 in there, and I added $20. I should have 100 plus 20, $120 showing up in the balance. So let's take a look at this. So I'll say the balance is $100. I'll say the transaction amount is 20, and I'll say I want to do a deposit. And now I double clicked that deposit by mistake. Let me start that over. 120, and I'm going to click on deposit. Now I've got $120. If I click on withdraw, I'm going to take the value that's in balance and subtract this amount, the transaction amount, from it, and I'm going to click withdraw, and I'm going to get, I double click that thing again. They're really easy to double click here. If I had 120 and withdraw that, I've got $100. So as you can see, it's really not much brain science or brain surgery going on here, but we're talking about handling these things in different ways for the purpose of this video, and I'll explain why we want to do that. But if you look at this, I mean, it really does seem like a good idea to get all of this complexity out of here, where it says how to set the balance or to get the balance, how to set the transaction amount or get the transaction amount, to do the things that I want to do. In particular, I want to be able to get the balance and transaction amount for each of these. And so I just have a method up here that does those, and we'll go look at those in a second. And then what I want to do is I want to set the balance using this guy right here for each of them based on what the transaction amount and the balance were. So I'm just getting rid of the ugliness of all of this code, of having all of this code down here, and making this call to it to get this balance amount. So this is really not tough to write. I mean, what I want to do is to set the text value in balance to whatever this value was, but I need to set it as a string. So I'm going to call float.toString, a predefined method in Java, in the Java environment, and I'll give it the value that I want to represent as a string, and I want to put it in the m_tf balance. I showed you where that was named. That m_tf balance control right there, that guy right there. And I want to do the same thing down here, but I want to calculate the value a little bit differently. So let's go and see how we go about getting the balance. There's a method called parse float that's a member of the float class. We've talked about classes in the previous video. We're talking about classes again, but this is a predefined class that's defined as part of the Java development environment, and as a result, we don't have to worry about how it works, which is something that we used to have to do. We used to have to write our own parse methods a lot. But now they're usually, in modern languages, they're generally provided, so because it's such a common thing to want to do. If you keep in mind, what we're doing here is we're taking the text from the m_tf balance, and we're converting it into a floating point value, and we're going to simply return it. What the user does with it, the caller does with it, we don't care. All we care is that we get a floating point value back. Now I want to show you something else here, that if we were to look at the design, well, let's come up here and run this thing again. If I have a balance of Dave and it comes up to get the balance out of there, well, that's bogus. It's not going to happen. And it happens when I call either one of these. I can say the transaction amount is 45, click on deposit, and it crashes. And it crashes because it can't take, as it says right here, it's got a problem number format exception for the string Dave, which is what I typed into the balance field. And it goes on to describe how all the way down into the depth of the code that's defined for us, where the error actually occurred. But the problem is that I want to get the balance, and I get it by getting the text from there, which is the string, whatever was in there, in this case DAVE, and tries to convert it to a float. And it fails because it doesn't make sense. We would normally want to do some checking on that in advance, or some try-case logic or whatever, try-catch logic, I mean, whatever, to keep that from happening. But for our purposes right now, we're going to just demand that the user enter values that make sense, because our purpose, again, is simply to talk about classes. So here's a class that we don't have to write, and this class represents all the floating point values in Java. And the Java data types are well known. And let me put this up here. And here's a description of it from Oracle. And I don't want it to be that big. I want it to be there. And the class float wraps a value of primitive type float in an object. An object of type float contains a single field whose type is float. In addition, this class provides several methods. So if you look at that in our definition that we had yesterday, or the previous video of a class, if you look at this, a class is a collection of objects and a collection of operations on those objects. Well, here's a class, and it's called float, and it's a collection of objects, and the objects are those things that represent floating point values, and the operations are, there's a variety of them, but one of them is to convert the object to a string. There's a bunch of others. All right, here are the methods that we can have. We can get a byte value or compare two floats or blah, 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 blah. There's a bunch of things here, all right? But for our purposes right now, we don't really care about that either. But except that we care that this thing, a float, is a class with capital F, is a class that contains elements, objects, with a single field, and that single field is a floating point value. So that's what's going on here. That's why we use capital float here to point all of this out. Okay, so what we've got is this collection of methods that we're actually performing on floats. Here's a value, here's a way that we can store the value on a float. Here's the way that we can get the value on a float. All right, now if you think about what we're doing here, and we look at this design, the thing that's described here is actually, especially this top piece right here, account number and balance. That's one of the reasons I put account number there like that, is actually a thing. And what we're talking about is an account. An account number 1, 2, 3, 4, 5, 6, 7, 8 has a balance of 0. It might also have somebody's name associated with it. It might have an inception date. It might have a variety of things about the account that may be important. For our purposes in this, simply going to describe an account as the account number and the balance. Then we have two operations. A withdraw operation, which withdraws an amount. So this is kind of a parameter into this operation. A deposit operation, which adds to or deposits money into the account. And so this is actually the argument also to this. So whichever one of these we click, it's going to use this value under transaction amount as the value to use as an argument. So actually what we need to do is we need to create an account class. And frankly, what's an account class going to have in it? It's going to have an account number and a balance. And if you keep in mind again, the account class is just like any other class, and it has a collection of objects. In this case, the objects are, if you think about it, members of the set string cross float. All right, so if we think of the account number as a string, the balance as a floating point value, then every account object is composed of an ordered pair, the first element of which is the account number as a string, and the second element of which is a floating point value, the balance. Okay, so those are the objects. Whatever objects you want. We don't even say that you can't have a negative balance or a zero balance. We have a zero balance now. I could put in, I could do, where are we? I could do this, start out the balance at 0, and do a transaction amount and a withdrawal. There's a withdrawal. I have a negative balance. There's nothing wrong with that, at least not by the code we've got so far. So if we look at this, we see that we have a collection of objects. The objects are string cross float members. All right, so a string that's an account number and a floating point number that represents the balance in the account with that number, along with two operations. That's an ideal situation because that precisely describes an example, a specific example of a class, a collection of objects, accounts, operations on those objects, withdraw and deposit. That's what this is all about. That's what we're talking about today. And now what I want to do is go motivate the purpose of having our own classes. In particular, we need to create a class account. So let's go back over here and look at this. What's the problem with what we've got? Seems pretty good, actually. I mean, we can deal with the account, we can get its balance, we can set a transaction amount, but nowhere do we actually have an account object except what's implied by the design here. These values, this value, this argument to these two operations. If we look down here, where is this now? Right here under generated code, you'll see that there are in fact some things that behave something like an account. We have we have these guys. These are the fields, and there are the two buttons that represent the operations. But that really still isn't quite what we would think of. If we look over here, if we look in here, we can see the code that's associated with performing the transaction. The problem with what's going on here is we don't have an account thing in the same way that we have a float thing, or in the same way that we have a checkbook user interface thing. What we need to do is to somehow come up with a way to describe an account without regard to the way it's going to be used, or without regard to how the application wants it to look, but with regard to how we want it to look. If you'll look at this right here, this is how we start creating a class. We say public class and give the class a name. We then proceed to give the class descriptions of how these objects are going to be organized and what these operations are going to be on the class. And that's what we're going to do next. So the first thing that you should be thinking about doing is coming up with some kind of an application that you would like to write. And I don't so much expect you to write it, but it wouldn't hurt you to write it in the form that you see with this. This is a non-object oriented form or layout, if you will, architecture. But what we're going to do now is we're going to create an account class here. You can come up with something else. I won't allow you to create things that have to do with video games because you got to stretch your minds, and I know you get plenty of exposure to that. I think you need to start thinking about other things as well, and so none of your applications can be about video games. You can pick almost anything else you'd like, but come up with something that's very simple in terms of trying to do some calculation or trying to manage certain objects in some way. Calculations are really the easiest thing to do at this point, and we'll get fancier as we go. But with that said, I'm going to finish this video. I'm going to come right back to this screen on the next video, and we're going to tear this thing to pieces and rearrange things in a way that will allow us to do a lot of different things. And also I will talk to you about at the very front end why we need to tear this up, why this isn't the best of all worlds here. Right now the only thing you have is that it's not the best way to do things because we don't actually have an account, a thing called an account. So that's one of our goals. Okay, with that in mind, this is about 20 minutes long, and I'm going to stop right there, and the next video will be coming shortly.